Well, welcome. In this video, we're going to be looking at lesson 4.2, which talks about how to work with negative exponents. Now, this topic can be kind of tricky. There's going to be a lot of information in this video. So it's going to be really important for you to follow along. And there's going to be parts to this video where I'm going to ask you to pause the video so you can try some problems on your own. It's really important, even if you're not 100% sure that you know how to do the examples that I'm asking you to work on, that you still pause the video and at least attempt them before hitting play and checking to see if they are correct. So again, as you're watching this video, when I ask you to pause it, please hit pause. Because then this way it'll seem more like a regular lesson. It'll allow you to interact more and take more from it than just sitting back and watching me perform. So you just finished working on an activity that's behind this little video screen right now. And you might have known how to do some of those problems. You might have struggled. But we're going to take a minute now and we're going to look to see what you should have gotten, what you should have done in that part of the activity. And then we'll move on to the key points on this lesson. Okay. So maybe you came up with some values like I came up with in this table. So maybe you just assumed that if you had a negative exponent, well, maybe that means that your base, that bottom number, would be negative. And since we know that when x was 1, y was 3, and when x was 2, y was 9, well, maybe that just means they're negative numbers. And when you had 0 as your value for x, maybe that just means that your answer is going to be 0. Well, the problem is, for one, it doesn't fit on your graph, and if it did, your graph is going to look kind of funky, especially after you graph it on Desmos. But I wanted you to take a minute to see that, because there's nothing wrong with coming up with a hypothesis and then testing it and finding out your hypothesis is wrong. So when you went to Desmos, this is what you should have seen. So as we look at this graph here, you can see that this graph goes infinitely to the up and to the right. So now you could answer some of those other questions that were on that activity. So let's see what you should have gotten from this graph. Now, what you should have noticed is, just like a parabola, this graph goes infinitely in both directions. So think about what that means for the domain. Hopefully you came up with it in your group, understanding that the domain is going to be the same as a parabola. It goes from negative infinity to positive infinity. But let's look at the range. Because as you look at this graph, you can see that this graph it gets really close to 0, but it never actually touches. I know that from the screen it looks like it touches where x is 0, but there's actually, if you were to zoom in, you'd see that it'd be hovering right above the line. That's because the line y equals 0 is an asymptote. We've talked about that before, meaning that it's not going to actually touch that line. It's not going to touch that value where y would equal 0. So what does that mean for the range? Well, that means that it's going to start at 0 and go infinitely up, but 0 is not included. So let's look to see how you'd write that in that activity. So you can see over here to my left, you can see that the range would go from 0, but not included, and go up to positive infinity. And then if we look above me now, if we look at the end behavior, on the right side of the graph is going infinitely up. So as x approaches positive infinity, the graph increases to positive infinity. And going to the left, as x approaches negative infinity, it's not going down to negative infinity. Instead, it's approaching 0. So that's how you would write your end behavior. Okay, so now let's look at some of the rules that you need to be familiar with before looking at the next examples. Okay, so the first rule we're going to look at is called the zero exponent rule. It's pretty easy to remember. All you got to do is remember that anytime you have an exponent of 0, your answer will always be 1. So x to the 0 is 1. Any number, any variable, even pi to the 0 power would be 1. Now the negative exponent rule, what that's telling us is that if you have a negative exponent, we can change its location to make it a positive exponent. So if that location is in the numerator, like just x to the negative a power, technically that means that it's in the numerator, we can move that to the denominator to make that exponent positive. So it'd be 1 over x to the a. Now, if it's already in the denominator, like the second part, then to make it into a positive exponent, we move it to the numerator. So let's look at some examples here where we're going to apply both of these rules. Now in this first one, we have 3x, the quantity 3x to the negative second power. Now the easiest way to do this is to make this exponent positive by moving that to the denominator. So this would be the same as 1 over 3x, the quantity squared. So now I'm going to square that entire quantity, the 3x. Now 3 squared is 9, and x squared would be just x squared. So our answer would be 1 over 9 x squared. At this point, I want to look to see if there's anything I could simplify, and there's not. So this is my answer. Now with the next one, we have a negative exponent in the numerator and a negative exponent in the denominator. What I like to do is I like to circle anytime I have a variable with an exponent. I like to circle that item and only that item. That negative 5 does not apply to the 5. That negative 3 does not apply to the 25. It only applies to the x and to the y. So this x to the negative third power, to make that positive, I'm going to move it up. That y to the negative 5 power, to make that positive, I'm going to move it down. So I know the 5/25 can be reduced, but I'm going to wait with that for right now. I'm just going to take care of these negative exponents. So I'll still have 5 in the numerator. Now this x, like we said, moved up, so it becomes x cubed. 25 stays down there, and the y comes down and joins it to become y to the 5th. Now I look to see if I can simplify or reduce this at all. And 5 over 25, that can be reduced. So my 5 goes into both of those. So I would have 1x cubed, or just x cubed, over 5 y to the 5th. And that would be my answer. Let's go ahead and try this third one together. There's a lot going on here. Here we have 4x to the negative 7th times negative 2x to the 5th times x to the 0. Now we know x to the 0 is the same as 1. Multiplying times 1 doesn't change the value, so we can ignore that. And now this negative 7 only applies to the x. So that's going to move to the denominator. A negative 2 does not mean that it moves. Remember the negative exponent rule? It's a negative exponent. 2 is a base. So we don't move that at all to make that positive. That's going to stay exactly as it is. The only thing I'm going to move is this x to the negative 7th to the denominator. So now I'm going to have 4 times negative 2x to the 5th with x to the 7th in the denominator. Or negative 8x to the 5th over x to the 7th. Now remember, we're not only working with numbers here when we go to reduce, sometimes we have to reduce with our variables. So I have x to the 5th in the numerator and x to the 7th in the denominator. Meaning I have 5 of them in the numerator, that's going to take out 5 from the denominator, leaving us with 2. So I had 7. So we're going to be left with 2 x's, or x squared, in the denominator. So here's your answer, negative 8 over x squared. I want you to take a minute, and I want you now to try these next 3 on your own. Some of them look tricky, but don't be afraid to use these little steps that I used where we circled. Anytime we had a variable with a negative exponent, we circled those. So I would encourage you to do the same thing and move those items. Or if it's a quantity that's got a negative exponent, remember to move the entire quantity like you will in example 4. So go ahead and take a few minutes. Try these next 3 problems. So I want you to pause the video at this point and hit play when you're ready to check your answer. Okay, let's see how you did here. So with this 2x to the negative third power, that's what you want to move to the denominator. So for this one, we're going to start out with 4x in the numerator with the quantity 2x being cubed in the denominator. Now let's simplify that denominator. 2 cubed is 8. So we have 8x cubed. Not only can the 4 and the 8 be reduced, but the x and the x squared can be reduced. Now remember, 4 divided by 4 is 1. And so don't forget that our numerator is not just going to be empty. We're going to have a 1 in the numerator and a 2 in the denominator. And with the x's, we have 1x in the numerator and 3 in the denominator. So I'm going to take 1x from the numerator and 1x from the denominator, leaving us with x squared in the denominator. So it's 1 over 2 x squared would be your final answer for that one. Let's look at number 5. So here we have a y with the -2 power in the numerator, and we have 2 items in the denominator that needs to move up. So a lot going on here. Kind of looks like a treasure map when we have to do all those arrows, but it makes things a little easier. So in the numerator, I'm going to have 10x squared. Now with it, we're going to move up the x to the -3 to become x cubed, and the y to the -1, we move that up to become y to the first. In the denominator, the 8 stays down there, and y to the -2 is joining it to be y squared. Now let's simplify. 2 goes into both 10 and 8 evenly to become 5/4. And with the x's, those are both in the numerator, so we just multiply those together, and that's going to become x to the 5th. And that 1y in the numerator takes out 1y from the denominator, leaving us with 1y in the denominator. So our answer would be 5x to the 5th over 4y. Okay, let's look at the next one. So the next one, well, y to the 0 is 1, so we can eliminate that. And then we're going to move this whole quantity and this variable to the denominator. And this is going to move up. So the only thing we're going to have in the numerator right now is z cubed. In the denominator, the x to the 4th will stay down there, but the 5x, that quantity, moved down to become the quantity 5x squared. And the z, oh, that already moved up. Oh, this z moved down, so this would be z squared. So now when we go to simplify this, let's simplify the denominator. So when we do that, we'd have z cubed in the numerator, but in the denominator we would have x to the 4th times 5 squared, or 25, x squared times z squared. So now in the denominator we have z squared, take out 2 from the numerator, leaving us with just 1 in the numerator. And then the denominator will have 25, x to the 4th times x squared is x to the 6th. So that's your final answer for that one. So I know this seems complicated, but practice makes perfect, so please make sure that you work on your assignment this afternoon to make sure that you get some practice in, because you'll want to make sure that you've practiced enough of these to know what you're doing. Now there is one more concept I want to talk about here, and that's this idea of scientific notation. Now we talked about scientific notation in the previous lesson with positive exponents. Now let's look at what's happening here in this top section so we can see how it applies to negative exponents. So if we have 1.2 times 10 to the -3rd power, well, from what we just learned, that's the same as 1 over 10 cubed. And 1.2 times 1 over 10 cubed gives us 1.2 over 1,000 if I simplified that. And if I divided that out, I'd get 0.0012. In other words, you can go to the final answer by moving the decimal. And we move the decimal in order to, if we have negative, or if we had positive exponents like we looked at yesterday, we can move the decimal to the right. Like with this example, 1.2 times 10 cubed is the same as 1.2 times 1,000, or 1,200. So we could just move the decimal to the right 3 places and get to that same answer. Where now, if we're dealing with negative exponents, we move the decimal to the left. So up here where we had 1.2 times 10 to the -3rd, I can move the decimal to the left 1, 2, 3 places, and I get 0.0012, which is the same answer as what we had down here. So let's look at some more of these. This first example, we have 1.25 times 10 to the 5th. Well, move the decimal to the right 5 places, and I get 1, 2, 5, 0, 0, 0, or 125,000. Now if I have a negative exponent, I'm going to move it to the left 4 places. So this becomes 0.00344. It's not that I'm adding 4 zeros to the front, I'm moving the decimal to the left 4 places. Okay, so now let's go over to the other part here where it says to rewrite these in scientific notation. So let's look at 5 and 6 together. So with number 5, this is a really large number, 5,500,000. So using scientific notation, you always start with one number to the left of the decimal. So we're going to move the decimal right here. So it's going to become 5.5 times 10. Now to move it right here, we had to move the decimal to the left 6 places. So that would be 5 times 10 to the 6th. So remember, with a large number, you're going to have a positive exponent. With a really small number, less than 1, we're going to use a negative exponent. So for the next one here, we would have the decimal between the 4 and the 5. So you always have one number to the left of the decimal. One number bigger than 0. So we're going to move this 3 places to the right. So again, since we're dealing with a small number that's less than 1, that means our exponent's got to be negative. So we moved it to the right 3 places, so it's going to be negative 3. Now, I want you to do 3 and 4 from the first set of examples and 7 and 8 from the second set of examples here. And so why don't you go ahead and pause the video at this point and hit play when you're ready to check to see if you have those 4 problems correct. Okay, so let's see how you did. With number 3, we have 2.27 times 10 to the negative 6. So what we're going to do is we're going to move the decimal to the left 6 places. So we would get 0.0000027 would be your answer. Or 1.3 times 10 to the 6, we're going to move it to the right 6 places to get 1300000, or 1,300,000. So now let's check to see how you did on the other one. So this one here, we're going to move the decimal to be between the 6 and the 5. So we'll have 6.576 times 10. And now to figure out what exponent we would use, since it's a small number, it's going to be negative. It will be negative 1, 2, 3, 4, 5, 6. Or this one will be 1.2 times 10. It's bigger than 1, so we're going to have a positive exponent. We'll have 3, 6, 9, 10 places to move the decimal. So 1.2 times 10 to the 10th. Now, how does this apply to your calculator? Because I have students all the time where they get an answer like this on their calculator and they think that there's something wrong, or they're trying to figure out what does that mean. And I've said it multiple times, but maybe you just haven't made the connection. Well, hopefully you can make the connection now. Because in reality, we know that this answer should be 0.000005. But our calculator doesn't say that. Instead, it says 5e negative 6. So do you see the connection here? This is really scientific notation for 5, or 5.0, times 10 to the negative 6th power. So if you see an answer like this come up on your calculator, please do not write it like that. Don't think that the e means that there's an error. It means that it's an exponent of negative 6. So 5 times 10 to the negative 6th. Well, there you have it. This is our lesson on negative exponents. Now, we covered a lot of material in this lesson. But remember, you have this video accessible to you now at any time. So feel free to always go back to it. You can skip to the parts that you want to specifically cover. You can always pause the videos at any time. So please make sure you utilize this tool that you have available to you. And with that, good luck now as you work on your assignment.